Welcome back, fam. This is James, the decomposer and the synthesizer of math and science tutor. But fit without a waste of time, remember this. If you're not well, if you're not good, take one day at a time. And in all that you do, don't forget to invite who? God Almighty. Alright? Guys, check it out. Today we're working on organic chemistry. We have a problem here, which is CH3CH in the brackets OH CH3. All right, so this is it's an organic compound that we're dealing with, right? So remember that an organic compound is basically a compound that is composed of carbon and hydrogen and other elements such as phosphorus, oxygen, and halogens, basically, you know. Yeah. Okay, so now how are you going to find the molecular formula of this guy? The first question is, before you even have to answer all these three questions here, number one, you need to know what is this that you are given. What I'm given here, this is one thing you guys should know. Those are in college and those are in high school, even the ones in varsity. I know that there's an advanced when it comes to organic chemistry first years and stuff, which I will touch it. Okay, so now what is more important here is that you guys need to pay attention to this, that organic chemistry or organic compounds, basically they can be represented in three ways: molecular formula, structural formula, and condensed structural formula. So the question is, am I given condensed molecular formula or structural formula? I'm given a condensed structural formula. What is a condensed structural formula? Guys, a condensed structural formula is a formula that shows it shows individual carbon atoms attached to how many hydrogen atoms without showing the bonds. Hear me out again. A condensed structural formula. This is a condensed structural formula. So a condensed structural formula shows you individual atoms in a compound attached to how many hydrogen atoms without showing the bonds. So in other words, you can see that we have 1, 2, 3. We have 3 carbons in a compound, right? So each carbon has how many hydrogens? This one has 3, this one has about 2, this one has 3. You see, that is what you call a condensed structural formula. Okay, maybe some people might have another way or to can explain it or and stuff, which is still good. If you feel like there is another way you can explain this condensed structural formula, please don't forget to subscribe, like, leave a comment there. Tell us what you think about it. You know what I'm saying? Awesome. So guys, let's talk about a molecular formula. Now, what is a molecular formula? A molecular formula shows the total number of atoms in a compound. So basically, when you're talking about a molecular formula, we're going to be talking about how many carbon atoms are in that molecule. So we have carbon and hydrogen plus oxygen, right? So a molecular formula will show you we have 1, 2, 3. There are about 3 carbon atoms in total. Let me just show you how we do it, because sometimes when you just explain without showing, some people won't understand or get it. So guys, check this one out. Okay, let me erase the molecular formula since I am touching it right now. Right? So 1, 2, 3. There are 3. So I'm going to be having C3. How many hydrogens? 3 plus 3 is basically 6, right? Plus 4, you're basically having 7. Someone can write it like this. So someone would be like, okay, what does this represent? How many carbons we have? 3 carbon atoms in this molecule. 7 plus this guy. Now this implies C3H, 7 plus 1, 8. O. Okay. Now this becomes your molecular formula. So molecular formula shows the total amount of atoms in that molecule. It tells you how many carbon atoms are in there, how many hydrogens are in there, how many oxygen atoms are also in there. That's what a molecular formula does, right? That's why we have something called isomers, which I'm going to come to that part. I'm going to come with the video of isomers. We'll be learning more about isomers, right? That they will have the same molecular formula but different structural formula and stuff. You'll learn more about it. So you can see that this is basically an alcohol because people see an alcohol using OH, like hydroxyl group, right? So it's an hydroxyl group. OH simply means hydroxyl group. It represents an alcohol, organic, a homologous series. So, which is the functional group, it is hydroxyl, by the way, of alcohol. So you can see that when I add this and this, they'll give me 8, and then I have oxygen, then I'm fine. That's what you call a molecular formula of this guy. So if they ask you, what is the condensed structural formula? Condensed structural formula. Condensed structural formula. You can see here, it's my molecular formula. My condensed structural formula will basically be what? Breaking down those carbon atoms, meaning how many each carbon must have its own total number of hydrogens. And you should know that every end, meaning any carbon atom that is at the end or at the beginning, will always have 3 hydrogen atoms. Any carbon within the chain, like those ones in the middle, for example, you see, I'm talking about this guy, must always have 2 hydrogen atoms or 2 bonds. But the one at the end must always have about 3 hydrogen atoms. And lastly, a carbon must have 4 bonds in total. 4 bonds. Carbon comes from group number what? Group number 4. It has how many valence electrons? 4. So how many bonds does it need? 4. What kind of a bond is needed? Covalent bond. So carbon atom needs a covalent bond, right? And we know we have different types of covalent bond. A covalent bond could either be non-polar or polar, which I'll also come to that part when we do molecular geometry as well, all right? Good stuff, and chemical bonding as well. Okay, so let me continue, right? Right now we need to give the IUPAC name of this guy. What is the IUPAC name, first of all? So if you want to identify the IUPAC name, let me do this. I feel like I was supposed to say C and B. No, this is wrong. This is supposed to be what? C. Yes. Yeah, no, it's fine. Yeah, this is the order basically. Structural formula, and then after we'll come to the IUPAC name. All right. So what is the structural formula of this organic compound? So the structural formula, it's so nice, right? The structural formula is a formula that shows the compound in it shows the carbons individually, right, with total number of hydrogens attached to, or certain atoms attached to them in a way, showing the bonds. This is my point. There are 3 carbon atoms, so there are 3 carbon, 1, 2, 3. You see, right? This one has 3, so I must put 1H. Let me use a different marker, sorry. Maybe to show. See, remember we said carbon must have how many bonds? 4 bonds. Look, 1, 2, 3, 4. And remember, carbon is one of the special atoms. It can make bonds with itself. This one, there is something called catenation. Is the ability in which carbon has the ability to form bonds with itself, like triple bonds, long bonds as well, which will come to it as well. Okay, so here, look at this one. It has how many bonds? CH. We have 1 hydrogen, but because of we have the OH, which is the hydroxyl group, which is in the bracket, it shows that this is a functional group. Remember, we have alkanes, alkenes, alkynes, haloalkanes, which are halogens, and then we have alcohols, right? And aldehydes and ketones and carboxylic acid and esters and so forth, right? And ether and yeah, so forth. So this guy's an hydroxyl group, OH. So I must put him here. Then this guy has how many? 3. So now check. 1, 2, 3. 1, 2, 3. You see? Now, I want you guys to have the understanding between a structural formula and a condensed structural formula. Guys, look. These two guys, they are the same, right? They have similarities. The only difference is that here, I remove the bonds, like these lines. I remove these lines. Then it's going to look like this guy. That's the only difference between a structural formula and a condensed structural formula. So here we show the bonds. You see, we show the bonds, but here we don't show the bonds, but we show that each carbon has how many? 3 It has like about 2 hydrogen atoms and 1 oxygen, which is here you can see. So that is the difference between a condensed structural formula and a structural formula, right? Good stuff. So right now, we are going to our last question, which is the IUPAC name, right? Yeah, guys, please, I'm giving you guys a homework. When I come back with another thing, with another video, you guys must be able to tell me. No, you must tell me right now. I must see you in your comments, guys. What does IUPAC stands for? Someone will say International Unit of Applied Chemistry. Someone will say International Union Applied Chemistry. Someone will tell me, there's guys, it comes up. It like in most cases you'll see it. Even in varsity you'll still find this one. Come multiple choice. So you better know what does each and every word stands for there. Okay, good stuff. Right, then now let's do the IUPAC name. The IUPAC name, basically, we are looking at the chemical name. We want the chemical name of that organic compound, right? So when you do the IUPAC name, there are so many rules that we need to follow, right? So that your IUPAC name is correct. So first of all, you need to find the longest chain. The longest chain, meaning that it mustn't break. You know, when I'm saying it doesn't break, when I'm saying, look, something like this, 1, 2, 3, and then I can put C here. Yeah, now let's see. Look, 1, 2, 3, 4. It's 4, right? Okay, 1, 2, 3, 4, 5, 6. 6. So which one is the longest chain here? Is it 4 or 6? 6. So meaning this guy is my longest chain. Since when we go 1, 2, 3, 4, 5, it breaks. You see, look, 1, 2, 3, 4, 5. Oh, we can still make 5. But between 4, 5, and 6, which one is bigger? Sorry for that. 6, right? So when I go 1, 2, 3, 4, 5, it breaks. So I'm not supposed to go like that. I'm supposed to find the longest chain without breaking. Like this. 1, 2, 3, 4, 5, 6. Then, this is my longest chain. And remember, in chemistry, we talk about meth, eth, prop, but, pent, hex, hept, oct, nano, deca, right? So meth means 1 carbon, 2 carbons, 3 carbons, 4 carbons, 5 carbons, 6 carbon, 7 carbon, 8 carbon, 9 carbon, 10 carbons. What do you want us? Yeah, get levels at the carbons. Okay, so right now you can see 1, 2, 3, 4, 5, 6. Which one? Hexane. We have hexane, or hex. You see, there are 6 carbon atoms. So this guy is gonna act as a branch. It's gonna act as a branch. We say that it's gonna act as a branch. I'll explain more about it, right? So let's continue, guys. Let's continue. Now check it out. We need to find the IUPAC name. Remember, the first rule is to find the longest chain, which is just 1, 2, 3. It's 3, and 3 it's prop. So I'm having prop already. Prop. Do I see any branch like another carbon or something? There's no branch there. If there are no branches, that's good. Now the most important part is to focus on getting the functional group. So who's your functional group in this case? Is it an alkane, alkene, alkyne, what? Is an alcohol. So we have an hydroxyl group here. And 1, 2, look, when I'm naming, when you name, you must start on the, when you start counting, start on the carbon that has, that is closer to the functional group. You see, so 1, 2, 3. Even if I go 1, 2, 3. So this guy is still on number 2. So meaning that my functional group is on number 2. So I'm going to call it who? Prop 2 propen. Propen 2 all. That's going to be my IUPAC name. Propen 2 all. Someone can say 2-propanol. Meaning that this number here, it tells you that the functional group of hydroxyl is on carbon number 2. And guys, you see, A carbon that is attached, a carbon that has the hydroxyl group, and that carbon is surrounded by two carbon atoms, or is attached to two carbon atoms, we call it a secondary alcohol. Secondary alcohol. We have a tertiary alcohol, primary alcohol, and secondary alcohol. I will explain that as well on the next video that is coming up, right? Awesome, guys. So that's the name that you guys can actually make out of this structural formula and this condensed structural formula. If you guys have more questions, you have more comments and stuff, or any suggestions, feel free with it. Okay, thank you so much. Then now, guys, let's look at something else. Oh, someone is asking me. I'm hearing someone saying, please show us primary alcohol. Okay, look at the primary alcohol. A primary alcohol. A primary alcohol is when the carbon that has the OH. Listen. A primary alcohol. A primary alcohol. A primary alcohol is when, or a primary alcohol is an alcohol that is attached to one carbon atom. The carbon that has the hydroxyl group, or that has the OH, should be, or it's a must for it to be attached to only one carbon atom. That's why we call it primary. It's a primary alcohol because this carbon that has the OH is attached to only one. Look, do you see any other carbon attached to this guy besides this one? No. So it's a primary alcohol. But the moment, sorry for that, but the moment I put OH here, it's not strong, this guy. The moment I put OH here, look, this is H, right? Now we have OH on the second carbon. Look at this carbon. This carbon that is in the middle is attached to two carbon atoms. It is surrounded by two carbon atoms. So whenever the carbon that has the OH, or the hydroxyl group, or the alcohol, is attached to two carbon atoms, we say that is a secondary what? Alcohol. Good. Now, what if we want to know about a tertiary alcohol? Now, if you want to know about a tertiary is an alcohol that is attached, is an alcohol or a carbon that has the OH attached to three carbon atoms. Check it out. Here's the black marker. Okay, sorry for that. Now, guys, check it out. Look at this guy. This carbon here, he's attached to how many carbon atoms? 1, 2, 3. So if the carbon that has the hydroxyl or the OH, it is surrounded by three carbon atoms, like 1, 2, 3, we say that that type of an alcohol is a what? Tertiary alcohol. Tertiary. Tertiary alcohol, secondary, and primary. So we have three types of alcohols. Primary alcohol, I've shown you guys. Secondary alcohol, you've seen it as well. Tertiary alcohol is the one that you see right here. Okay, so in case you have confused or you don't understand what is the difference between a primary alcohol, secondary alcohol, tertiary alcohol, I just did it for you here. If you want more video or more detailed in terms of on alcohols, please don't forget to subscribe. Don't forget to leave the comment there. Ne? Okay, thank you guys. All right, now let's move on quickly to something else. Okay, so guys, what do you guys think of this structure that I'm about to give you right now. How many? 1, 2, 3, 4, 5. Okay. I need to draw it here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, right? And then here. They'll say to you, give the IUPAC name. Give the IUPAC name. Remember rule number 1. What is the longest chain? 1, 2. Okay. Can you do that? 1, 2, 3, 4, 5. So my longest chain is 5. If it's 5, then I'm thinking about what? Pent. I'm thinking about pentane. Okay? But I cannot say pentane because it's an alkane. I must look at the functional group right now. So let's see the functional group. I see this double bond of, guys, this guy. If you see this guy, if you see the double bond of oxygen surrounded by 2 carbon atoms, hear me out. Hear me out for the last time. A double bond of oxygen, a carbon that has the double bond of oxygen surrounded or attached to 2 carbon atoms, that person, the name of that homologous series or that organic compound falls under whom? Ketones. Ketones. The functional group of ketone, we call it carbonyl. Carbonyl. Carbonyl is this guy. The double bond of oxygen with the carbon. Carbonyl. Okay? Ketones. As long, this is my point, guys. This is what I'm talking about. Do you see what's going on here? Forget about this guy. Let's forget about this whole carbon. Right? Look, the carbon that has the double bond of oxygen is attached to 2 carbon atoms. That guy, we call him who? A ketone. As long as there is no any other oxygen, there is only one oxygen in that compound and there's a double bond of oxygen, ketone. So let me remove him. Okay. Now, what if this guy who has a double bond of oxygen, that carbonyl, it's not attached to 2 carbon atoms or is not found within the carbon chain, but is always at the beginning, meaning here or it's here? What is that functional? What is that organic compound falling under? Aldehydes. Aldehydes. So this is my point. There's a difference, guys. That R that you see means 2 carbon atoms, right? So that carbon was attached to another carbon, which is the R, another R. There was a ketone. But now it's just 1 carbon and hydrogen. Who is that guy? Aldehydes. Remember, guys, aldehydes. So the aldehydes, they are the ones in which the carbonyl group is always found at the beginning of the carbon chain or at the end. Okay? Not within. And again, this carbonyl group or this guy, he's only attached to only 1 carbon, like this one. You see? My functional group, I'm gonna circle him, this guy. He's attached, the carbon that has him is only attached to 1 carbon. That's what we call aldehyde, Buffett. Don't be confused anymore. Right? Good stuff. Then, let's see. Remember the goal is to find the IUPAC name, right? We know now it's an aldehyde. Aldehyde, alcohol, some people might be asking, okay, how did you know that when you name alcohols, you must say ethanol, methanol? Okay, alcohols, they end up with OL at the end, like methanol, ethanol, you know, propanol, you know, you get. So, and then for aldehydes, we end with like methanol. I'm giving an example, methanol. I mean, let's just say ethanol, propanol, butanol, pentanol, hexanol. You see, so they all end up with AL. Those are aldehydes. The one that ends up with OL they are alcohols. But the one that ends up with like this, pentanone, they end with 1. Pentan 1, pentanone. Some 1 propanone, 2 butanone, like those, as long as they end up with 1, they are ketones. Why you call it a ketone? So we're taking this guy and we are putting there, you see. So ketones, Bafetu, pay attention to that. So that's the reason why, Bafetu, ne? All right. Then now, let's see. When I name this guy, do I really have to say his own carbon 1, 2, 3? Must I say 1 pentanal? No. Since the functional group is always at the end or at the beginning, there is no need for us to say 1 pentanal, 2 pentanal, 3 pentanal. No. You get it? With alcohols, we can do that because alcohols sometimes the OH is here, it's here, it's here. You get, that's why we have to see, you need to show 2, 3. You get it? And then with ketone, you must say that because it's always within the carbon chain. And then carboxylic acid, there is no need. Alkenes, there is a need. Alkynes, there is a need. Alkanes, there is no need. Haloalkanes, there is a need. Like 1 bromo, 3 bromo, 1 chloro, or 6 chloro. You get what I'm saying? Yeah. So those are the things, you guys. Yeah. All right. So here it's just going to be what? Pentanal. Pentanal, and you just add your AL there. Pentanal, because there are 1, 2, 3, 4, 5. Pentanal. That's the IUPAC name of the structure. I hope it wasn't that difficult. But how about I do this? Let me see what. 1, 2, 3. Okay. Now there's a difference, guys. Look, 1, 2, 3, 4. That's my chain. Look, 1, 2, 3, 4. Okay. Let me remove this one here so that I cannot confuse you. 1, 2, 3, 4. Someone can say 1, 2, 3, 4. Oh, it's 4. Then you're done. No, it breaks. Remember? Let's find the longest chain. 1, 2, 3, 4, 5. Between 5 and 4, which one is longer? 5. So meaning the 4, it was breaking a lot. So yeah, let's limit. So it's 1, 2, 3, 4, 5. 5 is still what? Pent. Let's look at the functional group. We have aldehyde is here. It's always at the end, right? So meaning when I count naming my carbon atoms, I must start from where? Here, from this carbon that has that functional group. So 1, 2, 3, 4, 5. 1, 2, 3. On carbon 3, there is someone else who is not really part of the longest chain. If there is 1 CH, I strong in. If there is 1 CH3, that's what we call methyl. If it's CH3, CH2, ethyl group. CH3, CH2, CH2, propyl group. They get a branch. They are still more. Isopropyl and butyl, they are still there. Okay? So there is 1, which is this guy. He's a methyl. On position what? 1, 2, 3. Someone can say, what about 1, 2, 3? Still the same way. 1, 2, 3. 1, 2, 3. Okay. So if maybe from when we were counting from here, it was 1, 2, 3. He was on number 4. When I count from here, he's on number 3. Which one should I take? The lowest one. Between 3 and 4, which one is the lowest? 3. So I will take the lowest one. So in this case, since everything is balanced, then I'm just going to say 3 methyl, 3 methyl pentanal. 3 methyl pentanal. So that's our IUPAC name of this compound. Yes, yes, yes. Hope you guys see that, right? Yeah. So how about I do this, guys? Because I want you guys to understand something. I can remove this guy now. and just put H, and now put this guy here, meaning now I put H here. Let's do something crazy, guys. Okay, 1 2 3 4 5. Okay, 1 2 3. It's less. 1 2 3 4 5. Oh, okay. So how should I name it? People prefer the longest one. So if I'm counting from if I'm doing the longest one, which is 1 2 3, or the straight one, 1 2 3 4 5, I must check there is another carbon that breaks this chain, right? Like 1 2 3 4. You see, then there's another one which is not part of the chain. That person becomes the branch. So if there's only one carbon, so there's supposed to be H here, then it becomes methyl. All right, so now let's do this, guys. Let's do this. Check it out. 1 2 3 4 5. If I name from here 1 2 3 4 5, this guy will be on carbon number 4. And carbon 4 and carbon 2, which one is between 2 and 4, which one is the longest or the highest? It's 4. And we must always take the lowest and always use the alphabetic order when you're doing the IUPAC names, guys. Don't forget that. So which one is correct? 1 2 3 4 5. Remember, it's going to be 4 methyl pentane. Why is it a pentane? Because they are all single bonds, right? Alkanes, single bonds. So it's going to be 4 methyl pentane. Let me tell you something. You are wrong. You know why? Because you need to check the branch. The branch must be to the lowest. We take the lowest substituents, by the way. So it's 1 2. On carbon 2, there is the branch. There is that branch. So this is the correct IUPAC name. 2-methyl pentane. This is wrong. This is correct. Okay, I'm gonna make more videos about IUPAC names. You know what I'm saying? Showing you from all different question papers, so that you guys can actually understand more. You know what I'm saying? Awesome, guys. Right? Okay, guys. Now, guys, can I do something with you? The same structure. One, two, three, 4. I don't have to put another hydrogen here. You know why? Because carbon needs only 4 bonds. So in case you are asking yourself, why is he not putting another hydrogen? Carbon must always have 4 bonds. Even if you count here, you will see. Look. 1, 2, 3, 4. 1, 2, 3, 4. Everyone has 4 carbon atoms. Now, here's the thing. You are given this structural formula. You know the IUPAC name, right? Because you can see 1, 2, 3, 4, 5. We said it's pentenyl, right? Because there are 5 carbon atoms and the functional group of the carbonyl is at the end or the beginning of the chain. So it's basically an aldehyde. So right now they are asking you to give a condensed structural formula. Condense. So when you condense, to condense is to you are compressing that one. When you compress it, it takes away those lines, those bonds. So I'm gonna be having here. It's gonna be what? CHO, CH2, 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 CH3. Let's see if it's correct. How many carbons? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. How many hydrogens here? On this carbon? 1. How many oxygens? 1. This carbon has how many hydrogens? 2. What about this guy? 2. What about this guy? 2. What about this guy? 3. What about that guy? What about... You see, that is the order. That is how you show a condensed structural formula. Imagine you're given this guy, you need to go back. Guys, there's a difference. This guy doesn't look like alcohol. If it was like this, Even if they don't put him in the brackets, maybe. Usually they like putting him in the brackets, ne? It's rare. Alcohol must always be like this. It means there must be CH2 to can have this one. That's an alcohol. So there's a difference between these two guys. And if you see this guy in the middle, let me show you something. I don't want people to be confused. Like this guy, CHO, no, CH3, and then CO, CH2. Let me confirm something. Yeah, it's fine. Yeah, if it's like this, ne, you should still know that this guy, this carbonyl is in the middle. Whenever the carbonyl is in the middle, we must always expect to ketone. Okay, right? Don't forget this. Don't forget that. And I'll show you different types of organic compounds with different functional groups, because in an exam you will be given that table which they will say use letters to say, okay, what is the IUPAC name of that letter, what is the functional group of that letter, you know, right? So yeah, I'm gonna do those question papers with you guys so that you understand these things much better. All right, awesome. Okay, now the last part that I would like to touch is what we call esterification, guys. Now, someone can ask me and say, what is an esterification? Esterification is a reaction in which, or a process in which an alcohol and a carboxylic acid reacts together to form an ester in the presence of a catalyst. You get? So that is what you call an esterification. And during that esterification, the product is always an ester plus water. But whenever you are forming an ester, you'll have an ester alone, right? So the water always gets eliminated through in the reaction of an esterification. So it's given like this. This guy, he's an ester. This guy, he's an carboxylic acid. Do not confuse these two guys. You will see. This guy is a carboxylic acid. Carboxylic, let me show you something about this guy called carboxylic acid. Before the ester, esterification or an ester, let's talk about this guy. Ester comes from alcohol plus carboxylic acid. Okay, ester comes from alcohol plus carboxylic acid. So this guy is always having OH. This guy is having COOH. Let me write it nicely so that you can see. You see, look at the difference. OH, alcohol. OH of the alcohol plus the carbonyl. Look, hydroxyl plus carbonyl, or carbonyl plus hydroxyl gives you carboxylic. So the carbo comes from the carbonyl. That xylic comes from the hydroxyl. Then we have an acid there. So that's an carboxylic acid. That's an carboxylic acid, Buffett. I hope you see that. Ester, alcohol, OH, carboxylic acid, COOH. Okay, right. I hope we're good on that one. Right. So let's try to make an ester reaction, guys. Let's try to make an ester reaction. So we just mentioned that for us to can make an ester, there are two reactants that we need: alcohol and carboxylic acid, right? All right. Think about this. Any reaction requires a catalyst. all right, to conform that product or that certain product or to yield that product. We need to have that catalyst and also heat it up. So what kind of catalyst is it needed during the esterification process? Do not forget this. We need concentrated H2SO4. Who can tell me what is this guy called? We need sulfuric acid. We need concentrated sulfuric acid. And remember, the concentrated sulfuric acid, they differ. You might have the 98% one, you might have the 90 something percent, they differ in terms of their percentages as well. Even when you're in the lab, you will see work with different, okay. So we need a concentrated sulfuric acid. This guy, he is the catalyst. The catalyst that is born, it will never change. The catalyst of an ester is always who? Sulfuric acid. Doesn't change. When they say give the chemical formula, listen, give the chemical formula of a catalyst of that ester. This is the chemical formula. Give the chemical name of the catalyst of that ester product, sulfuric acid. There's a difference when you write them, like when you write these two guys. Chemical name, chemical formula, or this is what you call the common name of that catalyst. I agree in grade 8 and 9 when they ask you to you won't start by saying sulfuric acid. It's a common name, sulfuric acid. But what is the chemical name of this one? Di means two, so dihydrogen sulfate. Dihydrogen sulfate. That's what you guys gonna say, right? It's not a problem. Okay, so let's continue, guys. I have an interesting thing to show you guys. Look. So what happens is that I'm going to eliminate someone. This guy, he's going to go with this H. And then at the end of the day, we have plus. That is when they talk about esterification behind the scenes, this is what we do. We have alcohol and carboxylic acid. We want to form an ester. There's a catalyst, of course, here, which is the sulfuric acid. Okay. Then from alcohol, the OH and the H from the carboxylic acid. That H that's coming from, that is of the OH from the hydroxyl, is gonna go with the OH of this guy. Then they will give you the H2O. Then these two guys will remain here. Plus this guy. So that's what we have. That's what we have. Yeah. Okay. Now, let's do it nicely because some people might not really understand this. All right. Let me say I have ethanol. Ethanol plus who? Propanoic acid. Whenever you see oic acid, propanoic, methanoic, butanoic, ethanoic, oic acid, those are carboxylic acid, right? Okay. Then we have ethanol and this guy. So let's draw the structures. Ethanol means we have two, so I'm gonna just make two. Yeah. Okay. Plus propanoic is supposed to be 3. Look, 1, 2, 3, 4. Everything is 4. 1, 2, 3, 4. And a carboxylic acid, but let me tell you something. This carbonyl and this hydroxyl, they must always be at the beginning or at the end of the carbon chain. Like, you must never see this guy in the middle. No, they must always be at the end. That's carboxylic acid. Ne? That's why you never see two propanoic. No. Okay? Yeah. All right. Then now what's going to happen? Remember the catalyst? In the presence of someone, right? I can just do it like here. And then remember HSO4. It's concentrated. So remember, I want to show you how to, because they will say to you in an exam, draw the structure. Show the structure of F and what. So you need to know when F is alcohol and C is carboxylic acid, the structure that you're going to form is going to be an ester. But how do you do it? So I'm showing you behind the scenes. So I'm going to take this guy. He's going to come and bond with this guy. I'm not really doing the mechanism of varsity. If I do the mechanism of varsity, I'll need to talk about nucleophilic and whatnot. Not yet. Okay. Yeah. All right. Yeah. Checking which one is more electronegative and electron rich areas. Nah, not yet. Not yet there. Okay. Then these two guys will give us water and then we'll remain with these guys. So we're going to have C. Remember, the moment this OH goes, this guy, he needs to bond. So he's going to bond with who? Here. This oxygen also, it's also having someone, it's also like having a gap. It needs someone to can bond to. So we're going to take that oxygen and put him here. Then these guys can come. Right? Let's see. 2, 2. How many? 1, 2, 3. And don't put this guy here or here. This guy must always be close to that oxygen atom because he was always close to him. Right? So basically, it's like I took this guy, put him first. The other ones will be, you get what I'm saying? It's like swap. So, yeah. Anyway, just to connect them. Our goal is to connect this oxygen with this carbon here because they need to bond, both of them. And carbon needs to bond to be stable. So now you can see you have that that ROOR. You see? Sorry. You have that ROOR, which meaning you have two oxygen atoms. Whenever you see that, it's an ester. Don't even think twice, straight ester. Which comes from who? Alcohol and carboxylic acid. So now you need to name. Exactly. What now it gets deeper. You must give the IUPAC name. Now you must give the IUPAC name. Hey, check it out. Check it out, Buffett. Okay. To give the IUPAC name for esters, alcohol will always take Ly. Right? And then carboxylic acid will always take oid. So if you want to name this guy, he's going to be ethyl. You see? You remove anol. That anol, you remove it. Then you're left with eth. So ethyl who? Propanoid. Oid. This is the name of an ester, Buffett. Ethyl propanoid. Now, someone can say, okay, what if it was methyl Okay, I'll do it, it's fine. Okay, but now put in mind, ethyl propanoid, that's your carboxylic acid. Sometimes they can take this guy on the other side, this guy on the other side. As long as you still see the oxygen between them and the carbonyl group here, it's an ester. Okay, so let me do just one more. Okay, let me just say we have methanol plus who? Plus ethanoic acid. Make an ester, make an IUPAC name from here. Okay, so already I'm gonna say methyl, because I just showed you, right? Methyl who? Ethanoid. Methyl ethanoid. What about I'm having propanol plus pentanoic? No, not really pentanoic. Methanoic acid. What about this guy? Propanol plus methanoic acid. So it's gonna be what? Propyl methanoid. I get it, this guy is like this. If you didn't know, this is methanoic acid, by the way. 1, 2, 3, 4. There's still 4. That's methanoic. So methanoic plus propanol, they will give us propyl methanol. Guys, I hope now you know how to make an IUPAC name of an. It's not that difficult. IUPAC name of an ester. If you didn't really understand in this video, please let me know. I will just make a special video for esterification, special video for alcohols. Just let me know, guys. My goal is to assist you. My goal is to make sure that you guys understand at the end of the day. Do not forget to subscribe, to like, to share Bafethu. All right? To glory be to God, Bafethu. As I always say, don't forget to invite God in all that you do. Don't forget to pray. Life is so spiritual, Bafethu. I love you all.